if we look at this point, if I ask you to graph this, what you're thinking of is I'm going to look at the angle 0 as my positive, like my initial direction in which I'm going to look. The theta tells you how much we need to turn. So we need to turn 180 degrees so that we are now looking out towards angle pi. When we look out towards angle pi, we then take this number of steps. So if I make this tick mark number 1, this tick mark number 2, this right here would be the point 2 comma pi. Always the angle that we're concerned about. This is the number of steps we take in that direction. Okay, so for number 1 through 4, I just want you to label these. If you went to the next couple pages when we actually graph equations, you're going to see what a polar graph looks like. They look like this. It's like these little circles around. You don't necessarily have to draw this in right now. It's not crucial for us to be able to do these 4 little problems. If I ask you to graph this, this is telling you, look at angle pi over 4. So angle pi over 4 is right here. So we're going to be looking in this direction at pi over 4. And this tells us how many steps we want to go in that direction. So each circle is a step. So here's step 1, 2, 3, 4. That is point A. If you look at point number 2 or point B, if we look at 5 pi over 4, 5 pi over 4 is the pi over 4 angle down here in the third quadrant. So this is 5 pi over 4. So we're looking in this direction. That's if you were standing here, you turn so that we're looking in this direction. But if you notice that our radius is a negative 4, what that means is while we look in this direction, since we have a negative r, that tells us we go backwards 4. So that means we actually go 1, 2, 3, 4 backwards. And what we find is that's just a different way of labeling point A. So point A and B look different, but they ultimately are the same exact spot on our coordinate plane. That's a negative r. Letter C, or yeah, I guess point C, number 3. If I give you a negative angle, same thing we would do with the unit circle. If this is angle 0 right here, negative pi over 2 means we don't go counterclockwise, we go clockwise. So you're going to be looking at the pi over 2 angle down here. So we're looking here. And then since we have a 2 for our r, this is the point C. Letter D. Now this is a positive angle, so now we do want to go in our regular counterclockwise direction like the unit circle. So this tells us we're looking in that same direction. Notice I tell you 2 steps out. Those 2 points end up being the same as well. So a lot of different ways that we can name these. There's really an infinite number of ways that you can name any point on our coordinate plane. Along those lines, 5 and 6, if I ask you to find all polar coordinates from each point, it's a couple different ways we can do it. I think the simplest way is let's keep this 3 positive. Let's keep our angle pi over 4. And then what we would hopefully know is if I just go around 360 degrees or 2 pi, we should end up right where we started from. So I could do 2 pi and then multiply by n. That just gives me all polar coordinates of this. We could, you don't necessarily give me too many of these, but just like we did above, couldn't we also now call this 5 pi over 4? So look in this direction, but just give a negative 3 so that we go backwards while we look in that direction. And then do the same thing as we add 2 pi however many times. That would then get us to that same point over and over and over again. Yeah. So isn't this 5 pi over 4 here? So if this is Pranav, and you're looking at angle 5 pi over 4, and then you go backwards 4, that takes us here, right? So if I add another 2 pi, so this is you, doesn't that just spin you around so that you're once again looking out at this angle? Because all I did is spin you around. But if I now go backwards 4, I'm still going to end up right here. And as we just keep going around 360, we're always looking in the right direction and taking those 4 steps backwards. All right, and then 6 real quick, we'll do a negative 3. we'll just keep this short and sweet and simple. Just look at pi over 4. As long as we continue to go around 360 degrees, then we end up at that same point. You can try to name that with a positive 3, with a negative pi, there's different routes you could take with all of those. All right, these guys, equations now. If I ask you to, instead of just a single point, graph this equation. So draw a little XY plane there. Yeah. Sure. Good. So Ethan said that's going to be a circle. That is 100% correct. I don't give you an angle. Our radius is constantly 2. So no matter what angle I look at, 0, pi over 2, pi, 3 pi over 2, any angle in between, if my r is always a 2, all that really is then is a circle with a radius of 2. Which then makes number 2 super easy, because same exact thing, right? So if this is a radius of 2 with a circle, this should just be a bigger circle with a radius of 5. So that's how we can get a circle in polar notation. 3, a little trickier. If we do this one now, there's a nice geometric word for this. The theta tells us what we're looking at, the direction in which we're going to look. So if we are right here, we're always standing at the origin, and then we're looking at pi over 6. So we're looking off in this direction. And then we would want every r value equal to or greater than 0. So if I had the actual polar graph drawn in, I would want a radius of 1. I would want a radius of 2, and then 3, and then 4, and then 5. But there's nothing saying it has to be a whole number or an integer. It could be 1/2, 3/4, and when we now start dealing with all the decimals, what we really are dealing with then is a ray. So we're looking at pi over 6. We take every positive step in that direction. That's how we can get a ray extending from the origin. Four then. Actually, do 4 real quick while I draw it, because this should be pretty similar. But it just kind of gets at what we did with those first 4 at the top of the paper, where we talk about there's just different ways and understanding what a negative r, negative angles give us. If I'm looking at pi over 6, that's where we're looking right now. So we're looking in this direction. But if I now want to take every possible step backwards, that means while I look in this direction, I would go back a half step, 1 step, 2 step, 3 steps, all the steps in between. So we get another ray, but it's now going in the opposite direction of number 3, because we want our r's to be negative. So just to make sure, let me erase this so we don't think there's any part of this. That's what our graph would look like there. Right. Okay, 5. Do 5. This one you should be able to do and be able to say a name of. It's easy ways to describe this one. Do you have a packet of this, Sean? Oh, okay. I was going to say, I think I have some up there if you needed one. Okay, should be a nice, easy way to explain this one. This to what?
I'm thinking like a shaded area.
How much of it? Like, it is a shaded area. Good. Good. Should be a quarter of a circle. So if we go from angle 0 to angle pi over 2, so we want all the angles in the first quadrant. That's what this is telling us. We want every r of 1, so that would give us the quarter circle of 1. We want every r of 2, so here's 1, here's 2. But we want every r in between, so we would want the radius of 1/2, of 1.6, and as we start drawing them all in, then this just becomes a completely solid shape. So it's kind of like a quarter donut, a quarter washer from our washer method days. All right, but it's just a quarter, okay? 6 should be nice. Draw that one in. Another one that we should be able to draw and describe easily. Now we have a nice geometric word for this. This should be a what? Not a line. Line segment, yeah. This should be a line segment. So you're going to look at pi over 4, so that's 45 degrees. That's where we're looking. Maybe I should put the polar graphs into these. So we're going to go to a positive 2. We're going to go to a positive 1. We're going to do all the ones in between because of this part, every positive radius up to 2. And then we want every negative radius to the negative 3. So if I give a third circle here, -1, -2, -3, everything in between, we get a nice line segment in there. All right. All right, let's see. Let's try to get these 3 done at least, and then give us a little something to do at the bottom of the paper tomorrow. Try this one. This one's interesting. No geometric shape name for this one. At least not that I'm aware of. All right, what do you think, Ethan?
This gets screw at these cars.
Not quite everywhere. Except for what?
Oh, sorry, I thought I was reading that 0. So except for the circle before 0.
Yeah. So here's the circle of 1. So if this was just r equals 1, that's our circle. But we want not only that circle, we want every other circle greater than 1. So we would want 1.1, so right on top of it, then 1.2. And then if all of the radii after that get shaded in, then it's that. All right. So if you come up with a nice name for that, let me know. All right, 8s should be nice. We've already done one similar to this. Try one more time here. So you're going to go negative pi over 2 to pi over 2. We want all radii between 1 and 2. So like the one we did before, we had a quarter of a donut. Now if we're going to go from negative pi over 2 and then to 0 up to positive pi over 2, so up in here with every radius of 1 and then a radius of 2, so call this 1, 2, -1, -2, and all radii in between, we now have a half of a washer. Looks like an ear, actually, now that we do it on this. Or half of a donut. The last one. Another one, I don't know what you would call this. Let's see what you think. That's not bad, actually. I think of it as like a flashlight, as it opens like a spotlight. But yeah, an endless slice of pizza would be pretty good. So here's 0. Pen would work. So here's 0, pi over 6, we'll say is here. So we have to stay in between there, but we want every radius towards pi over 6, every radius towards 0, along with every radius in between. So if we did that, then yeah, it's kind of this endless slice of pizza. All right, so those are our inequalities and equations for these. All right, with that, this will work out good because it makes you check, gives us something to do tomorrow, so I don't tell you to completely take the day off. So we'll do the bottom of this paper, and that's probably what we'll just get through tomorrow. Actually, there's one on the set of notes from, where is it? Day 3. I want you to see this question here. This is very much a valid question that long-term you want to know how to do for both our purposes, for AP test purposes. So I want to do that question. We'll do those 6 problems at the bottom, and then whatever time that takes tomorrow will be our day, okay? If you have any question on your test or quiz that you didn't want to ask in front of everybody, you got a minute or two now, hang out a minute, I can pull it up and take a peek. But if you're good, have a good night. We'll see you tomorrow. Thanks, Pranav.
I'm not sure what that is, but I'm going to be enforcing the first few days.
Yeah, just a second.